Hello, what's the Warden, and today we'll be solving the problem 3 of the 2018 NMC Second Round. So this is a geometry problem. I've already included the diagram. You're actually given two equal segments, AB and CD, and we are told that E and F are the midpoints of AC and BD respectively. You're also told that AC and BD meet at T, as I've already indicated, and that the perpendicular bisectors of AC and BD meet at W, as I've already indicated as well. So WE and WF are perpendicular bisectors. Now I asked to show that ABW, CDW, and EFW are similar. So first of all, let's start with what we have, right? So we are given that AB is equal to CD, E and F are the midpoints, so AE is equal to CE, and BF is equal to DF. Also, we are also told that WE and WF are perpendicular bisectors. So we can actually use that to establish some kind of similarity, which is always present whenever you have perpendicular bisectors. So let's start with WF, right? WF is a perpendicular bisectors. We have that, of course, BF equals to DF. We also have that, of course, angle BFW is equal to angle DFW, since they are both right angles there, because it's a perpendicular bisector. And then, of course, FW is equal to FW, since it's the same line. Now, this is perfectly enough for us to establish a side angle side similarity using the side angle side postulate rather. So from this, we can conclude that angle triangle B FW is similar to triangle DFW. And from this, you can get a bunch of other interesting facts. First of all, we get that WB is equal to WD, which was what I was actually looking for. But we also get some other things, one of which is angle BWF is equal to angle DWF, right? So similarly, if we do the same thing for W, if we do the same thing for WF, okay, this one was for WF, if we do the same thing for WD, we'll come up with a similar this thing. So we'll get that AEW, or triangle AEW, is similar to triangle CEW. And you also get that WA is equal to WC. And angle AWE is equal to angle CWE. Right, so what next can we do? So from this, we can notice something, right? We have that AB is equal to CD here, right? So we have AB equal to CD. We also have that WB is equal to WD, right? So we have this is equal as well. WB is equal to WD, right? And also that WA is equal to WC from here. So we have WA equal to WC. And now you agree with me that from this is enough to establish a side similarity, right? So basically we have AB equal to CD, WB equal to WD, and WA equal to WC. So from this, we have three corresponding sides equal. So you can perfectly establish a side similarity and conclude that triangle ABW is similar to triangle CDW. And this is actually half of what you are trying to prove, right? Right, this is actually half of what you're trying to prove. What's left is just to show that triangle EFW is similar to either of these, right? And if you can do that, you are done. So to do that, we can take note of something else of interest. From this similarity, for example, we can conclude that angle AWB is equal to angle CWD. And if we add angle BWC to both sides, angle AWB plus angle BWC, let's say angle AWB plus angle BWC is going to be equal to angle CWD plus angle BWC. Now, AWB plus BWC is going to sum up to AWC. All right, so you have angle AWC is equal to, and BWC plus CWD is going to sum up to BWD. So we can conclude that AWC is equal to BWD, right? So what next can we get from this? So this is telling us that those two top angles, AWC and BWD, are equal, right? What next can we get from this? Remember, I'm trying to show that EFW and ABW are similar. So at some point, we want to bring that in. All right, so okay. Now to do that, let's consider triangles BWF and AWE. So consider the two triangles BWF and AWE. Right? So basically we have angle BWF is equal to angle DWF. So of course they sum up to angle BWD, so they're going to be equal to half of that. Then we also know that angle AWE is equal to angle CWE, right? And then they sum up to angle AWC, so they are going to be equal to half angle AWC. Right, so we have angle BWF equal to half angle BWD, and angle AWE equal to half angle AWC, right? And we know that angle AWC from here is equal to angle BWD. So we can conclude that angle BWF and angle AWE are equal. So we have that angle B. So this is going to imply that angle BWF is equal to angle AWE. All right, so next, what can we do? Also, from this similarity, we can get something else from, okay. So now we have that angle BWF, right, is equal to angle BWE plus angle EWF, right? So this implies that angle BWE plus angle EWF is equal to angle ABW, or angle AWB rather, plus angle BWE. And now with this, you can take angle BWE from both sides. to give us angle EWF is equal to angle AWB. Right, so basically we have these two angles being equal. Remember, we are trying to show that we are trying to show that AWB and EWF are similar. So we are kind of on the right track, right? So all that is left to do is show that all that is left to do after showing these two angles to work with the SAS postulate, all that is left to do is show that AF, AW, let me put that here. All that's left to do is show that AW over BW is equal to AW over BW, yes, is equal to EW over FW. Right, and then we can easily get that from this similarity. Here. So for now, I have not yet established the similarity. All we know for now is that angle BWF is equal to angle AWE. So we also need this ratio to establish the similarity. Now to do this, we'll take note of the fact that angle BFW, let me clean this. So this is actually what you're required to prove. We have not yet proven this. So let me erase that and continue our work there. So now again, we are considering these two triangles, right? And we have that for now that angle BWF is equal to angle AWE, right? From here. You also agree with me that angle BFW is equal to angle AEW, since they are both right angles. And with this, we can easily establish a similarity. We have two angles equal, or two corresponding angles equal, so the third corresponding angle has to be equal as well. So now these two are actually similar, right? So this is going to imply that triangle BWF is similar, to triangle AWE. And from this, we get the ratio we need. So we can actually get that BW over AW is equal to WF over WE. And coupled with the fact that coupled with the fact that angle EWF is equal to AWB, right? So we have that AW over BW is equal to WF over, or WE over WF rather, right? So, and we also already have that these two angles are equal. So that's enough to establish similarity that triangle ABW is similar to triangle EFW. And now since ABW is also similar to CDW, we can conclude that they are all similar, and that solves the problem. So we have our QED right here. So this will be the end of this solution video. See you all in the next. Thank you.